Welcome to episode 8 of this Houdini Vex series. Let's talk about two more functions that will encounter you in many scenarios, Primuv and Xyzdist. These two are often mentioned in the same context, since they play together very well. Primuv interpolates the value of an attribute at a certain parametric position. Xyzdist finds the distance from a point to the closest location on a surface geometry. Xyzdist can also output a primitive number and a UV coordinate of the closest primitive to a point, which the Primuv requires as an input to sample attributes from that specific primitive. In the Houdini docs on the Xyzdist function, you will find some arguments with an and sign, here marked in yellow. These mean that the Xyz function can give you a specific values when you write an attribute name here. Let's dive into Houdini and take a look at what both functions do on their own, and then at an example of a combined workflow. Let's use the Primuv function to offset this pighead object along our curve. The first thing I did is I created a curve, in this case a line, I deformed it, and used the polyframe to get some normals along our curve. Then I also added a color ramp, and now we are using the attribute wrangle to get our attributes from that primitive. So a curve consists out of many points, but only one primitive, so we can say it's always 0. Then in our wrangle we add 1 point, it's just a point, and the second input is our curve. So now, in order to use our Primuv functions, we first need to create two variables. One is the prim number. In this case, it's 0, since we only have one curve in here, and it's 0. And also we need a u value to sample our attributes from. When you have a surface, it will be the uv value, but since we have a curve, and you can describe it in parametric values only with one dimension, so we only need the u value. So let's first use the Primuv function for the first input. Remember that this is the input 0, this is the first input. And we want to get the position attribute from our prim, which is 0, primer number, and from the parametric position u 0.05 in that case. We store that. So basically what it does is it looks at the curve at the parametric value of 0.05, and then samples, okay, at what position is this parametric value in space, and we store it in this variable. Then I put it to my point, so at p for my 1 point is this position value. Since now we have a rising u value over time, the point is getting pushed along the curve. You can sample every kind of attribute you want. So for example, the color or the normal, and now set them to our point. So if we copy 2 points, our pighead geometry right now, you can see that it will run over our curve. Let's see what we can do with this Xyzdist function. So I have this test head geometry here. I create some normals and scatter some points. I use the peak node to push them away from the head. Maybe let's template the head and use a little bit of jitter. So now we can calculate the closest distance from each point to the surface. Input 0 is our points, input 1 is our surface. So now our float dist variable is the output of the Xyzdist function of the first input. The first thing is our position, and now we can also add attributes here, the hit prim and hit uv. When we do so, we have point attributes, so it tells you not only the closest distance from this point to that surface, but also which primitive it hit on that surface, and also what uv value there is on that surface. This is quite important for us, since we need to feed these values in our Primuv. So these UV values are not the UV values you know if you have spacebar 5 and you have real UVs. These are parametric UVs. So basically you have each primitive, and each of those primitives have one parametric UV. So it's in U, it's from 0 to 1, and in V or Y, it's 0 to 1. And then on here, where the point is the closest, this is the parametric UV it will output on your attribute. So let's continue. Now that we have the distance, we can set it to the p-scale and then copy our spheres to on that point. It will detect the p-scale since it's a keyword, and we can merge it with our head. You can see that each of these spheres, none of them is intersecting with the head, but they're all touching the head, since we have the radius p-scale of those spheres driven by the distance the points are from the head. Let's have a look at a combined workflow and see how we can stick those heads to an animated character. So first I used the Greg animation. It's this test object. I created some point normals, and now the first thing I did is I time shifted it. So I freezed it at frame 0. Now I scattered some points onto it. I used the p-scale to set a random p-scale attribute, and also I point jittered it around, so they are not laying on the surface anymore. Now let's get the XYZ dist. First I want to store a float attribute called dist, so I have the points distance to the closest surface. Also I want to store the hit prim, so the primitive it's hitting, and also the UV. Now those values are fed into my primuv function. So here as a second input I have my animated character this time, and the first input are my points. So now I sample the position of, and I can use my hit prim and my hit UV attributes I saved with this XYZ function. So each point knows its prim and its UV value it's referring to, and I sample the position and the normals from there. Then I set the position and the normals to my points. You can see that these points now are sticking to the surface and also have the right normals. Now I can copy my heads onto my animated character, and that's basically it. Now each point is sticking to the surface with the right normal.